welcome to a special report from the Cosmic Companion for July 24th, 2020. White dwarf stars are known to explode under certain conditions, but the causes of these events remains a mysterious process. However, the detection of a flash of ultraviolet light from one of these explosions could help answer questions about these stellar eruptions. This is just the second time such a flash of energy has been seen by astronomers during one of these events. This finding could also help researchers better understand the formation of heavy elements such as iron, as well as providing a look at one of the great mysteries of the universe, dark energy. The ultraviolet light tells astronomers some very specific things about how the white dwarf exploded. As time passes, exploded material is moving further away from its original source. Now, as that material thins, investigators will be able to see deeper into the remains of the object, and after a year or so this material should be so thin that they will see all the way to the center of the explosion. In December of 2019, astronomers at the Zwicky Transient Facility in California spotted a supernova they dubbed SN 2019 YBQ. Analysis of this data revealed this was a Type 1A supernova, a fairly common type of explosion for white dwarf stars. Taking place roughly 140 million light years from Earth, this event was seen near the tail of the constellation Draco. Type 1A supernova are some of the most common explosions in the universe, but what's special about these events is the UV flash. Astronomers have searched for years, and this most recent event was only the second time such a UV flash has been seen and associated with a Type 1A supernova. The production of ultraviolet light usually suggests processes happening at temperatures several times hotter than the surface of the sun. This display lasted for several days, suggesting an energetic process caused this unusual flash. However, white dwarfs usually become cooler over time, so this finding confounds researchers. Currently, astrophysicists have several theories on why these white dwarf stars occasionally produce flashes of ultraviolet light before exploding. Some stars in binary systems consume material from their partner, building up until the material reaches a critical mass and the star explodes. This is what causes a Type 1A supernova. Now, expelled material from the eruption might race outwards, colliding with the companion star, generating an ultraviolet flash. Another possibility is that radioactive material in the core of the white dwarf might mix with the outer layers of the star, raising surface temperatures to a range where it radiates in ultraviolet light. A third idea holds that helium ignites thermonuclear reactions in carbon within the star, resulting in a strange double explosion producing the ultraviolet flash. Another possibility is that the ultraviolet radiation comes from material ejected by the collision of a pair of white dwarfs. Most of the iron in the universe was produced in Type 1A supernovae. Some of that iron goes on to produce planets, including the core of the Earth. By learning more about these explosions, astronomers hope they might learn about the formation of our own planet. Type 1a supernovae are all believed to explode with a particular certain brightness. By measuring the apparent brightness of these events as seen from Earth, astronomers are able to measure distances to far-flung galaxies. This is similar to if you knew the strength of flashlight. You could tell the distance someone was standing from you by measuring how bright the flashlight appeared to be. And now, by measuring the Doppler shift of these galaxies, which is the change in frequency of light seen in moving objects, astronomers are able to determine the velocity at which the universe is expanding. With a more complete explanation of the mechanisms behind these explosions, astronomers could get a more complete understanding of the dark energy driving the expansion of the universe. Most galaxies are actually moving away from us. Now, when a type 1a supernova happens in a distant galaxy, astronomers can use it to measure a combination of distance and velocity, allowing the researchers to determine the acceleration rate of the universe. Dark energy remains a mystery, but these supernovae are the best way to probe dark energy and to understand its nature. Billions of years from now, our own sun will become a white dwarf in its final age, although it will not explode like the pair of events recently seen by astronomers. Once the region around this star clears, the remnants left behind will provide researchers with an unprecedented look at how white dwarfs explode as supernovae, giving us a better understanding of the cosmos. For more details on space and astronomy news, please visit thecosmiccompanion.com or thecosmiccompanion.net.